Thanks, Andy, for giving us a chance just to talk a little bit about FIRST Robotics. I'm John Crombie from Bishop Foley Catholic High School over in Madison Heights, and we've had a robotics team for about 9 years or so now. FIRST Robotics, FIRST stands for Inspiration and Recognition of Science and Technology. And it was founded by Dean Kamen in 1989. And he founded it because he realized that young people today basically had their priorities wrong, okay? Their idea of a hero was somebody who was a rap star or an athlete, and that's who they wanted to be when they grow up. I want to be a rock star, I want to be an athlete. And we as parents looked back and went, no, the odds of you being a professional athlete are slim, and the rap star is not exactly what we had hoped for you for your future. So he formed FIRST Robotics as basically a competition of the mind. And unlike a typical science fair, which is not very interesting for spectators, he wanted to combine the best elements of sports and the competition and the excitement with engineering and science and the ability of teaching young people to think. And so they created this FIRST Robotics. It started out with just a few dozen teams out in the east coast United States. And Dean Kamen's the guy who invented the Segway, by the way, in case you wondered if you recognize the name. But it has grown now to the point that it's not just high schoolers, but it's actually grade school, middle school, high school that compete in this. And right now there are about 248,000 students across the country and actually around the world that compete in FIRST Robotics. And there are about 22,000 teams that are formed. Now, most of those are FIRST Lego League, where they build robots on Lego, out of Lego components on a 4x8 sheet of plywood, basically, and they learn to compete, and they learn some basics of even sensor recognition and that. Then there's FIRST Tech Challenge, which is for high schoolers, but on a real small budget and a little smaller scale. And then kind of the graduate version is FIRST Robotics. And right now, there are almost 2,100 FIRST Robotics teams around the world. There are 37 different countries that get involved in FIRST. There are FIRST Robotics teams in every state in the United States. Michigan is one of the top ones. We have 172 teams that have 172 schools that have a FIRST Robotics team this year. Last year was 130, so we gained 40 new teams this year alone. So basically,
One state, by the way.
What's that?
It's the #1 state.
#1 state in the United States, right, for robotics. And the other thing that's really neat is there are 66,000 mentors involved in the FIRST Robotics. So basically, that's the thing that separates it from many other robotics competitions or science competitions or anything else. It's not just give the students a task, set them loose, and some number of weeks later they come back and they compete. That's great, and that's all good, and they do learn a lot of real-life skills. But what's special about FIRST is that the mentors themselves are engineers and scientists and professionals, and they teach the students how to solve these real-world problems. So they work together. The students do the work. They're supposed to be the hands-on guys, but the mentors are there on maybe a 4-to-1 ratio if you look at the numbers to help the students, figure out how to solve these problems. So the students learn. They learn why they're taking these things in school. And it's really great when I see our juniors and our seniors who are taking physics and calculus and everything, and they come to me after they've taken physics and they go, now I get why we calculated the gear ratios or why we had to use chains instead of belts here or whatever, because they understand torque and they understand angular momentum and acceleration and all the other stuff. So it's really valuable. But basically what it is every year it's a different challenge. We don't know what robot we're going to build. And the first weekend, basically in January, there's this kickoff that's broadcast all over the world on NASA television and on the web and every place else. And all these 2,000 teams find out what the challenge is. And just to give you an example, last year was kind of like soccer. There were 2 goals at each end of the field. The fields are typically about 55 feet long and about 27 feet wide. And there were 2 goals at each end. It's played 3-on-3, 3 red and 3 blue. And your goal was to put soccer balls in the goals, right? There were 12 balls you would play with, and there were these bumps that you could drive over about a foot high on a 45-degree angle, and you drive over these bumps to get to the other side of the field, or you would pass them to your partners because it's 3-on-3 and there were 3 zones. That's what we did last year. This year, we're picking up these tubes that are either circle, triangle, or square-shaped, and we're racing across the field and hanging them on pegs, and there's 18 pegs on each end of the field, 3 teams, and the race is in 2 minutes, how many can you score? And so I always liken it to the last 2 minutes of a basketball game. You know how intense it gets when the score is tied with 2 minutes to go, right? Okay, imagine that with no timeouts. No chance to stop, no chance to hold a meeting, no chance to, that's it, time out. Time goes, and in 2 minutes it's over. And so everybody's going crazy. The stands usually have 2,000, 3,000, 5,000 people in it. When we get to the World Championship, which is St. Louis this year, was in the Georgia Dome last year, you're talking 20 or 30,000 people, big 100-foot Jumbotron screens, television broadcast, everything. It's amazing. But a lot of pressure for these young kids to actually drive these robots. But they have 2-minute matches, and the first 15 seconds is autonomous. So this gets down to what you guys were talking about building sensors to figure out how can you get the robot to achieve the task, by itself. And they give you a camera in your kit of parts. They give you wheel encoders for measuring your movement across the field. And then you can buy whatever else you want. So we buy ultrasonic sensors, we buy line following sensors, we buy all kinds of things so we can determine where we are on the field, and we write software to help determine that. The robots themselves are about 2 feet by 3 feet in dimension, and they can't be more than 5 feet tall when they start. Now they can expand out much bigger than that. And their weight limit is 120 pounds, not including the bumpers or the battery. So by the time you throw that all on, you're about 150, 160 pounds. And they do that because these kids have to carry them and they don't want anybody getting hurt. So they're about 150-pound robots, and the speed of them varies based on how you design it. Our robot has a 2-speed transmission, so it goes 4.5 feet a second in its low gear and goes 18 feet a second in its high gear. Well, it's a 55-foot field wide and only 27 feet wide, so in a second and a half, basically, it's pretty much going the entire width of the field. So it's fast and harder to control, but it's with the automatic shifting. It's kind of neat. The electronics are controlled by C-RIO, which is made by National Instruments, and the programming is done in either LabVIEW, Java, or C++. And they give them a toolkit with the basics to basically be able to drive it, okay? But anything beyond that, the kids write the software to do everything themselves. And what they write is amazing. I mean, there are autonomous routines that sense objects, drive across the field, put them on the rack, can drive back, get another one, go up and put it on the thing, and all this happens in like 15 seconds. Then they have the end of the match, and the end of the match is usually a period of 10 or 15 seconds where they have some other way of bonus scoring. This year, you have a mini-bot, which is like a small robot stored on your robot, and in the last 10 seconds, you can deploy that robot onto a pole that's 10 feet high, and there's 4 of them, and it's a race to the top. So at 10 seconds, the color of the towers change, and the robots can be deployed, and they race to the top. And when we did our original design and planning on how we wanted to do it, we said we wanted our robot to be able to be deployed and go up to the top in 3 seconds. And you had to make it out of a very standard kit of parts, which was really slow. And everybody said you couldn't do it. Well, at 3 seconds, you'd be slow today. The fastest teams can do it in 1 second. They can take the robot off of their robot, put it on the pole, and race it to the top in about a second. So it's amazing what solutions the kids come up with. But what's even more amazing is they do this in 6 weeks. So they find out the first weekend in January, here's your task. Build a robot, here's a couple of basic kits of parts, things you start with, and make it be able to do all this stuff, and you've got 6 weeks to put it in a box or in a bag to do the whole thing. And the kids do it. They start out, they brainstorm, they play the game physically. Then what we do is we do a rough CAD design, then we start building prototypes, and then we find out what works, then we do final prints, and the kids manufacture the parts, and they assemble them, and when they get it together, they wire the whole robot, and they get all that debugged and working. Then they program the robot, they have all the software working, they hook up all the sensors, they build a control board with all of the drive systems, and then they practice driving, and they put it in a box, and they do all that in 6 weeks. So it's an incredible accomplishment. And you guys talked earlier about teamwork and working together, and boy, you really see it on these teams, because most of the kids, they learn electrical, and another year they'll do mechanical, and another year they'll do programming, another year they might do the control systems, or there's the entire business end of the thing, because to run this program costs anywhere, it's just $5,000 to get in the application fee, basically, to enter the events. But it costs another $5,000 just to buy parts and that kind of stuff. But a typical team, really, to run it properly, is about $50,000. And if you know what our high school budgets are nowadays, it doesn't come from the high school. They don't have the money. So they go to sponsors like General Motors or Chrysler or whoever can help them. And these people help contribute mentors and money to help pay for the development of these robots. But it's a fantastic experience, and it gets back to what the panel was saying earlier about, I wish I had this stuff in high school, because I didn't really learn it until I did it. When these students graduate, they have amazing skills, and when they hit college, they hit the deck running. I mean, they know how to do stuff, they know how to work as a team, they know how to get things done. And speaking of college, FIRST Robotics sponsors and companies this year are giving away $14 million in scholarships to our high school seniors to help fund the expense of going to college, because they don't want these brilliant minds going to waste. And that is really the goal of this, is to develop our young people to make heroes of science and technology leaders, not just sports stars and entertainment stars, because we know that's where our future as a country lives. When I grew up, an astronaut was a hero. I mean, I looked up to Neil Armstrong. I thought that was pretty incredible in 1969 when he stepped on the moon, right? Today, they don't have those kind of science and technology heroes, and so the goal is really to re-inspire the youth of America to pursue careers in science and technology and engineering.
Great, thank you.
Thank you.
Appreciate it.